So before we get started, I just want to acknowledge that this webinar is being hosted in the unceded Mi'kmaq territory of Kjipuktuk, also known as Halifax, where there is a long history of colonialism that to this day has significant impacts on Indigenous peoples. And there is a need for change in settler societies to undo the attempted erasure of the Mi'kmaq. And so we need to continue to have conversations regarding climate. And when we do so, we need to consider the values and perspectives of Indigenous peoples and the work that they do and to amplify their voices. Because not only do they have a right to be part of those discussions, but they are certainly leaders in environmental and social justice for sure. So that being said, and bearing that in mind, I'm going to go ahead and introduce Valentine Gomex. He is an engineer, a passive house designer, and Living Future accredited professional residing in Charlottetown, PEI. And today he is going to be chatting with us about the importance of embodied carbon and why we need to be thinking about it when we design and construct buildings, and when we're advocating for things like better building codes. And so, yeah, I think without further ado, I'll just hand it over to Valentine, and you have the floor.
Thanks, Claire. I'm going to just kill the video here just to make sure all the streaming is good. Okay, so good afternoon, everyone, and thank you for taking the time to be here and learn a little bit about embodied carbon. A little bit about me. My name is Valentine Gomex, and I started Gomex Engineering in 2018, based out of Charlottetown, PEI. I'm a professional engineer here on the island and the current president for the Association of Consulting Engineering Companies, PEI chapter. I'm currently the only certified passive house designer and LFA on the island, and I try to look at all my design projects through these two lenses. In addition, I also offer services as a whole building lifecycle assessment consultant, which we'll be discussing further in this presentation. And I've adopted this from a colleague, but I am what we call a good building activist. Good building is a term that we started using instead of green building. I've heard a lot of people in my career say they don't want a green building, but it's pretty hard for someone to tell me that they don't want a good building. And most importantly, I'm a concerned parent, one that's trying to do my part in creating a better planet for future generations. I'd also like to give a shout out to these three gentlemen who, in my opinion, really are the leaders when it comes to tackling embodied carbon here in Canada. Without their hard work and research, we would be so much further behind in our understanding of embodied carbon in the built environment. A lot of what I'm presenting today is the summary of information and reports compiled from them, as they were the ones who really shed some light on the big picture for me. So I really like relating this analogy of the flat earth to embodied carbon, since the belief of the flat earth carried through to 500 BC. Hopefully it doesn't take us 500 years to realize the importance of embodied carbon in the built environment, but the main point is people just weren't aware back then. My goal today is to try and raise awareness and hopefully shift the way we start designing buildings moving forward. Before we get started, touch on some basics and provide some background information on greenhouse gases and their effects. We're all aware of the Montreal Protocol and how 197 countries came together to try and fix the hole in the ozone layer. And it worked. The hole in the ozone is on track to repair itself over the next 43 years. Now we have another issue with our atmosphere, but this time it requires not only effort from a government level, but from a personal level as well. Human-caused greenhouse gas emissions is trapping heat in the atmosphere and raising global temps. Again, all countries have signed on to the Paris Agreement with the understanding that we're all collectively responsible to try and keep global warming under 2 degrees, and preferably under 1.5 degrees. However, current research is predicting we are on track to cross the 1.5 degree threshold between 2027 and 2042. Climate change is not a future problem, it's a today problem. The 4 main gases responsible for global warming are carbon dioxide, methane, nitrous oxide, and fluorinated gases. These gases will all need to be addressed in some form or another, and they all pack a different punch when it comes to global warming potential. Carbon dioxide, with a global warming potential of 1, accounts for 76% of all greenhouse gas emissions. Conversely, fluorinated gases only take up 2% of total global greenhouse gas emissions, but can have a global warming potential as high as tens of thousands. Both of these gases have decay rates up to thousands of years. You can take note of the numbers for methane and nitrous oxide, but for this presentation, I won't be discussing these two gases as they're mostly related to agricultural activities. As one can imagine, comparing these gases to each other can be difficult, and so CO2e, which stands for carbon dioxide equivalent, was created as a way to compare emissions from one various gas to the other on the basis of their global warming potential by converting the amounts of gases to their equivalent amount of CO2. I want to quickly touch on refrigerants with respect to Canada. I don't particularly like this graphic because it implies we finally found a green solution to refrigerants, when the reality is we've just slowly been replacing it with something less bad. For the case of HFOs, its low global warming potential is relative when compared to CFCs, but not low in reality. So in January 1st, 2021, HFCs was the typical blowing agent found in almost all spray and rigid foam insulation, which is now replaced with HFOs. It's important to kind of realize that a narrow focus on operational emissions can be counterproductive and have unintended climate consequences. The term energy efficiency misses the point when it comes to climate change. Energy and greenhouse gases are not necessarily synonymous. Energy efficiency is just one consideration in an overall greenhouse gas emission reduction strategy, but not a standalone solution to greenhouse gas emissions. I'll be using the terms embodied carbon, material carbon emission, and upfront emissions here interchangeably throughout the presentation, but just want to mention that they're all basically the same thing. The term embodied carbon has evolved over the years, and industry is now leaning more towards calling it upfront emissions. When we talk about the carbon footprint of a building, people typically tend to look at only operating carbon, but it goes much deeper than that. To assign proper definitions to these, operational carbon is the emissions derived through the use of the building from day one of occupancy till its end of life. And embodied carbon is the emissions related to make, install, use, and dispose of a given building material used in constructing the building till its end of life. Let's go ahead and unpack the image to the right. It's called the carbon life cycle and can be broken up into several stages. The A1 to A3 stage refers to the raw material extraction, transportation, and manufacturing of a product. This first stage of the life cycle is mostly controlled by suppliers and manufacturers. It is the responsibility of the designers to spec low embodied carbon building materials. A4 to A5 refers to the transportation to site and the installation of the actual product. This is where builders and project teams can control emissions. Can we reduce the impact of transporting things to site or reduce the carbon impact of installing those materials? B1 to B5 refers to the embodied carbon of the building over its lifespan associated with maintenance, repairs, replacements, etc. Notice operational energy down at the bottom used to or required to operate the building is noted here separately. C1 to C4 refers to the end of life stage and involves emissions from deconstruction, transportation, waste processing, and disposal. This stage can have varying results for emissions, mostly due to the high level of assumptions that have to be made on it that will actually happen to a product at its end of life in 60 or 100 years. The net result of all of these combined is the holistic picture we want to be looking at when it comes to embodied carbon. This image is also commonly presented in a table format, which may be more familiar to some of you. As I'd mentioned earlier, when talking about embodied carbon, which is the green line, notice that B6 operational energy is actually omitted. However, when discussing whole building life cycle assessments, the blue line, it is included. Some other common terminology we'll hear throughout this presentation is the A1 to A3 is often called cradle to gate. We'll be diving into this specific product stage more in the presentation coming up. A1 to A5 is commonly referred to as upfront carbon or cradle to site. And then cradle to grave includes all of your module A and then all of your module B, B1 to B5, and then all of your module C, C1 to C4. And then there's cradle to cradle, which takes cradle to grave a step further and includes emissions beyond the building life cycle that involves giving the product a second life under the reuse, recover, and recycle strategy. The construction industry is responsible for about 39% of overall global greenhouse gas emissions, with operational emissions at 28% and upfront emissions at about 11%. The graph on the right shows a code-built home constructed in 2015, and 20 years later, in 2035, the embodied carbon still accounts for about 60% of the total building emissions compared to operations 40%. If we're serious about hitting net zero emission targets by 2040 or 2050 even, we need to address both operational and embodied carbon at the same time, while we run the risk of striving towards net zero energy at the cost of net zero emissions. Typically, lowering operational emissions involve additional building materials and insulation. So in theory, our embodied carbon could go up as operational emissions come down, if not done responsibly. As we make strides towards lowering our operational emissions, we can see embodied carbon actually starts to become a larger percentage of the smaller pie, which further drives home the fact that we cannot reach net zero emissions without also addressing embodied carbon. Historically speaking, cradle to gate, which is the A1 to A3 module that I had mentioned earlier, is typically responsible for the vast majority of life cycle emissions, to the tune of almost 70 to 80%. To give you an idea of how much carbon emissions that is, and we're talking about, is a typical low-rise home in North America has an average carbon emission footprint of approximately 250 kilograms CO2 equivalent per square meter of floor area. Canada annually is adding just over 56 million square meters of low-rise homes. This equates to 3.1 million vehicles driven in 1 year, or about 3.6 coal-fired power plants running for 1 year. Again, keep in mind, this doesn't include any operational carbon emissions or commercial buildings. This is just low-rise homes. So what's Canada doing about it? Well, unfortunately, currently no Canadian building code considers the greenhouse gas impacts of material carbon emissions. This issue is amplified as upfront emissions become a larger contributor to greenhouse gas emissions than operational emissions over the next 2 to 3 critical decades. Especially if we're using building materials with high embodied carbon emissions to try and reduce the operational carbon emissions. Federally, Canada introduced the Federal Greening Government Strategy, which mandated reporting of embodied carbon in structural materials of new projects by 2022. By 2025, this would turn up a notch and mandate reductions in structural materials by 30%, along with complete whole building life cycle assessments. They also introduced LCA squared, which was designed to support low carbon procurement of materials. This policy only applies to new federally owned projects. And I believe there was an announcement today that this is actually being updated and being tightened to become a little bit more stricter and happen a little bit more sooner. On the provincial side of things, no province has come forward to specifically address embodied carbon head on, but BC is probably the closest, and that is largely in part to the work being done municipally in Vancouver. Vancouver created the Climate Emergency Action Plan, which sets a target of a 40% reduction in embodied carbon emissions by 2030 from their baseline 2018 year. Their green building policy for rezoning also mandates reporting of cradle to grave emissions. Toronto developed the Toronto Green Standard version 4, which mandates all city buildings and buildings being built to Tier 2 report cradle to site emissions for structural and envelope materials. Tier 3 buildings must demonstrate a 20% reduction in cradle to grave emissions against a baseline building. Edmonton currently only requires reporting of cradle to site emissions. I also want to quickly mention Vancouver's brand new near zero applied research program, where builders are actually being compensated financially based on the amount of carbon reductions they can achieve in their new builds. These are not dollar amounts to scoff at, and will be very interesting to see the final results of the program in terms of net emissions avoided. It would be wonderful to see something similar offered here on the East Coast. So let's apply this to an example and have a look at the significant difference we can make. This was a study done by Chris Magwood for a sample building modeled with a wide array of conventional and alternative building materials to determine the greenhouse gas impact of upfront embodied carbon emissions from using worst possible materials to typical construction materials to best conventional materials and finally best possible materials. I also want to point out that under Vancouver's new research program, even typical construction is still eligible for $15,000 back as a reimbursement or as a rebate. And the remaining two are eligible for the full $40,000 rebate. So it's quite easy to try and get these rebates and actually drive change in your buildings, even with the typical today's construction. So a little bit more about the study. It was covered over a 20-year time frame and combined the material carbon emissions and the operational carbon emissions of a two-story building built to Toronto's Green Standard Tier 5, which is essentially passive house, all electric with an air source heat pump to handle its heating load, along with Ontario's relatively clean energy source. The study highlighted the amount of years it would take operational carbon emissions to surpass material carbon emissions in each of these 4 sample buildings. So in our first sample building using worst possible materials, we actually see it takes 315 years of operational carbon emissions to surpass material carbon emissions. Dropping down to the second building with typical construction materials, we get 71 years, which is significantly better than the 315 years from the previous example, but nowhere close enough to helping us reach net zero by 2040 or 2050. In our third building, using best conventional materials, we actually see carbon being sequestered for about 45 years. So definitely better. And then in our fourth building with the best possible materials, we get an impressive 190 years of carbon storage. The study goes on further to compare the difference in net emissions over 20 years between a high performance and a low performance, i.e. code built building along varying degrees of embodied carbon. As you can see, it's the buildings on the right that we should be striving to build. So how are we going to get to net zero carbon or net zero emissions? We can set realistic thresholds for combined upfront and operational emissions. Carbon use intensity is used to steer the low-rise building sector in a climate positive direction that is measurable and achievable. And with this plan, it just basically shows us slowly moving towards the best possible materials. We don't need to be doing it today, but we just need to stop using these high carbon worst possible materials and just start slowly shifting the building industry. So we can do this by lowering upfront embodied carbon while maximizing carbon storage in building materials, decarbonization of our electrical grids to cleaner sources, and also maximize energy efficiency as required. Of these 3 aspects, upfront embodied carbon and decarbonization of our electrical grids is shown to have the largest impacts on lowering carbon use intensity. Decarbonization of the electrical grid is something that is most effectively tackled at the government level, while upfront embodied carbon is the area in which individual designers, builders, and homeowners can make the most difference in carbon use intensity. We should not set our expectations at mere carbon reductions. We should aspire to this type of realistic net carbon storage in all of our buildings. So I've mentioned the term carbon use intensity a few times now, but basically carbon use intensity, or CUI, is a metric that adds the home's operational carbon emissions and the energy source emissions to its material carbon emissions to demonstrate the total impacts of these emission factors. Since operational carbon emissions accumulate annually, the CUI metric is usually associated with a particular time period, either 20 or 30 years. Carbon use intensity examines all 3 aspects of greenhouse gas emissions from the low-rise building sector. The output unit is kilograms CO2 equivalent per meter squared. Only by considering all 3 emission factors can we design truly zero carbon buildings. Ignoring any one of these aspects of building emissions raises the possibility that our efforts are at best incomplete or at worst counterproductive. A zero carbon building needs to have a CUI of 0. So switching over to some design guidance, historically the structure and the building envelope take up the majority of a building's total emissions. So we'll chat about these 4 different materials and what we can do to design better with them. For concrete, it is the cement manufacturing process that drives the embodied carbon of concrete up so high. Ironically, CO2 with a global warming potential of 1 is actually considered a low global impact, or global warming impact, sorry. But the fact that the concrete is the second most consumed material in the world after water makes it a problem that we cannot ignore. So for best practices, you typically want to reach out to your concrete supplier and ask if they have available low carbon mixes, and if they have the environmental product declarations to go along with them, or EPDs. EcoPact by Lafarge or EvoBuild by Lehigh Hansen are 2 different low carbon concrete mixes from 2 different manufacturers that are both working hard towards creating a zero emission concrete mix. This is a race to the bottom that we can all look forward to. We also want to try to minimize cement. If the project schedule allows it, aim for longer cure times, increase supplementary cementitious materials, or SCMs, to the 30 to 40% range, or even see if CO2 injection is possible. As a side note, with concrete, we should also be trying to maximize recycled steel in the rebar whenever we can. Moving on to insulation. Insulation choices can significantly impact a building's carbon footprint for both embodied and operational carbon, either positively or negatively, depending on the material used. Operational performance targets should be balanced with embodied carbon targets, using natural materials that sequester carbon and blown-in insulation instead of rigid or spray foam applications are best for lowering embodied carbon. Avoid XPS, EPS, spray foam, polyiso, SIPs, and this includes ICF blocks. All of these insulations are petroleum-based products that require significant energy to manufacture, resulting in a high embodied carbon footprint. Where climate and project requirements allow, specify lower carbon alternatives. Steel typically isn't used commonly in low-rise buildings, but it is used in high-rise buildings and can be a significantly high percentage of a building's total emissions. So we'll chat about it a little bit here. Unfortunately, 71% of steel production today is made through a blast oxygen furnace that has higher emissions and uses less recycled content. Conversely, electric arc furnaces use 97% recycled content with 50% less emissions, but only account for about 29% of global steel production. So obviously we want to try and specify steel from electric arc furnaces, but unfortunately, there's just not enough recycled steel in the world out there. A lot of the steel buildings that we have up are typically still in place and are being used. So we try to specify it as much as we can, and we fill out the rest with virgin steel. Used braced frames instead of moments resisting frames as they're lighter. Use joists or truss members instead of rolled shapes, again, as they are lighter. And use higher grade steel in order to reduce material again, but you'll need to verify if the net emissions are actually better or not. Design for adaptability and deconstruction so that when the building does come to its end of life, it can be properly deconstructed and the steel can be reused. And finally, remember to right size members and not to opt for a one-size-fits-all approach. Wood is noted here because it does double duty in the sense that it sequesters carbon during its growth stage and locks it in for the life of the building. It should be noted that there are, of course, emissions related to the manufacturing and transportation of wood, but this is far outweighed by the amount of carbon stored. And this is a good thing, but again, we need to ensure it's being done responsibly. As designers, it's important that we only spec wood from certified forests. Luckily for us, Canada is a leader with sustainably certified wood, with BC contributing the most certified acres out of any province. Forest Stewardship Council, FSC, and Sustainable Forestry Initiative, SFI certifications evaluate for basic forest stewardship by ensuring that harvested areas are reforested, and that laws are obeyed and there is no unauthorized or illegal logging taking place. So not only do we want to be speccing wood from sustainably managed forests, but we also want to avoid wood harvested from old growth forest. When possible, try and use reclaimed, salvaged, or recycled wood products to prolong the carbon storage. And lastly, try and spec fast-growing wood since they store more carbon faster than the slower-growing trees. We want to design for durability. That involves ensuring the wood is protected from heat and water and it'll last the lifetime of the building. Understanding building science and designing vapor open assemblies will go a long way in terms of durability. Also, we want to be speccing the right structural wood, but like steel, we need to verify if the net emissions are better or not. Finally, we want to try and pick low carbon alternatives for the same application. Excellent example is OSB and plywood. Both have similar characteristics, but OSB has double the carbon footprint of plywood. So we know embodied carbon's not great. What do we have in our toolbox? And the reality is we can't manage anything we don't actually numerically quantify. And EPDs are exactly that. They're a third-party verified nutrition label of sorts for the environmental impacts of a certain product. And in our case, this would be building materials. Now, there are three types of EPDs. There's industry-wide type 3 EPDs, product-specific type 3 EPDs that are internally reviewed, and then product-specific type 3 EPDs that are third-party reviewed. This is the one that kind of makes sure that there's no greenwashing. So when reviewing EPDs, make sure you pay attention to get to the type of EPD it is. An important note that I also want to mention is although EPDs educate consumers on the product they're for disclosure purposes only, this means the product itself may not necessarily meet any environmental performance standards. Basically, just because something has a nutrition label doesn't mean it's healthy for you to eat. EPDs start first by defining the product category rules, which sets the boundaries within which products' environmental impact will be analyzed, i.e. Cradle to site versus cradle to cradle, etc. Then after the boundaries have been determined, a lifecycle assessment of the product can be completed and the results are inputted into an EPD format, which is then third-party verified before being entered into an EPD database. All EPDs are presented in a standard format that is ISO compliant. LCA standards follow the standard ISO 1440 and ISO 1444, and EPD standards follow ISO 1425 and EN 15804. EPDs are critical in determining the embodied carbon and other environmental impacts of products that we use in our projects. The more the AEC industry and building owners request and require EPDs, the greater the availability and accuracy of the data. This drives the market in a positive direction towards increased transparency, allowing stakeholders the opportunity to make more informed decisions. So whole building LCAs basically compile all of the EPDs for every material that's used and their quantities that's used in a building to determine the total environmental impact for the life of the building. So these would include the embodied carbon in the materials and then also the operational carbon for X amount of years. One of which is embodied carbon and is reported as global warming potential on a whole building life cycle assessment report. Typically, the sustainability consultant would design a baseline building as per normal construction practices for that area, and then apply reduction measures to the baseline building in order to achieve their target emissions. Whole building life cycle assessments are done via various software tools that pull data from specific EPD databases. So this list isn't exhaustive by any means, but GABI is one of the largest EPD databases in the world and includes EPDs from all sorts of industries, including building and construction. EC3, or the Embodied Carbon and Construction Calculator, is a free and easy to use tool created by Building Transparency that allows benchmarking, assessment, and reductions in embodied carbon, focused specifically on cradle to gate emissions of the construction materials only. It is an open access database of manufacturer-specific EPDs. I strongly recommend anyone wanting to find quick EPD comparisons of building products for their projects to check out this tool. For part 3 buildings, Athena is free, but mostly uses industry average values with very little manufacturer specific values for EPDs. So it's good in like your schematic design stage or early on. Tally is designed only for integration with Revit with limited EPDs, not a lot of Canadian EPD data, unfortunately. Tally Cat aims to solve that a little bit by integrating with EC3. And so it's pulling the database from EC3's database, which are manufacturer specific EPDs. This is available in its beta version currently, and it's available for download for free. But again, it's only a plugin for Revit. WB-LCA is specifically designed for construction and has a large database of industry average EPDs and manufacturer specific EPDs. So they actually run their own EPD database. And it's the most versatile software for available for part 3 buildings. Unfortunately, it can also be the most expensive based on the type of software you're purchasing. However, they do offer a free one-click LCA summer school where they will teach you how to perform whole building lifecycle assessments on their software, and it's very well done. Switching over to part 9 buildings, PH Ribbon was designed to integrate with the Passive House Institute's PHPP software. It's fairly new and has limited EPDs, I think like under 500. Software was designed in Europe, so it tends to have more European specific EPDs. In North America, most people are using the Beam tool, and it's by Builders for Climate Action. It's specifically for residential construction and is very user-friendly and also pulls its EPDs from EC3. So, whole building lifecycle assessments is still fairly relatively new. It's definitely not a perfect science, and it's constantly being refined. Some of the obstacles that have come up is there's currently no standardization between each software, so it makes it hard to compare one software's LCA to another. So if Tally is using an EPD database from Gabby versus one-click LCA using its own database, you have to be aware of where the product category rules lie, and if they're not measuring the same thing, then their results are going to be different. So it's really hard to compare that. So EC3 is working to solve this by looking at only cradle to gate embodied carbon. Whole building LCAs also don't currently include any embodied carbon data for mechanical, electrical, plumbing, or refrigerants for that matter. And so it only considers the building envelopes for concrete, steel, thermal, and wood. And we're lacking EPDs in the residential building sector. Commercial side is definitely leading, and residential is growing, but residential has a lot more to go, for sure. So the Earth's population is growing at breakneck speed, and this image is old, and I think we're already at 8 billion this year. We're going to need to construct more buildings to house all these people, and we need to be making sure we're doing it responsibly. This is a common thing that we've seen thrown around, that we're going to require to build a new New York City every month for the next 40 years to be able to house our entire population on the planet Earth. So this image was taken from last year's IPCC report and shows our window for staying below 1.5 degrees is very quickly closing. It is important to realize the compounding effect of emissions, and that emissions avoided today are worth more than emissions avoided later on. By how much exactly? Keaton Josie put out a report on the pathway to net zero emissions by 2050, comparing the difference in addressing emissions on the front end, which is this graph down here, versus the back end, which is up here. So basically now versus later. And it's roughly 4 times more emissions released into the atmosphere if we wait later to curb emissions. So this is a great little mnemonic I like to use for designing good buildings, and we basically just need to start building smarter. So super insulated, mechanically ventilated, airtight, really good windows and doors, thermal bridge-free design, and always considering emission reductions and doing everything responsibly. I encourage you all to think about the embodied carbon of the materials you're choosing for your next building project. The impact you make on climate change is real and it's significant and should be started today. Hopefully I've helped shed some light on embodied carbon and the importance of addressing it if we were aiming for net zero emissions in the next 20 or 30 years. That's it for my presentation. Thank you all. I can try and answer any questions you may have now.
Okay, that was great, Valentine. Thank you. I especially love the part on kind of the like practical advice when you're looking at different building materials like concrete and steel.
Yes. A lot of people, even the insulation, for me personally, when I was learning this stuff years ago, like insulation was what blew me away. Was, you know, you kind of just think of insulation as doing good and saving you on your operational energy. But then when you start looking at the embodied carbon for stuff like XPS, and you're just like, these are actually horrible products for the environment. And the thing that really needs to happen is that EPD, that nutrition label, really just needs to, one of the things we in the industry are trying to push for is to have EPDs provided on every building material, like exactly like a nutrition label is on all food at the grocery store. So that when someone walks into a Home Depot and they're looking at insulation, they can say, okay, well, this insulation has the same performance as this insulation. They both cost the same, but this one is significantly better for the environment. So I'm going to choose this one. But right now, the average consumer doesn't have that data available to them, and they're not necessarily aware about it. And so that's kind of why I do these talks.
Yeah, this is definitely, I think, the first time I've heard about EPDs. So I will be thinking about them a lot more when I'm giving people advice on how to insulate their homes, for sure. Yeah, thinking about things like you know, advocating for embodied carbon in things like building codes, I think is super important, and something that I know a lot of work is going into right now.
Yeah, I do foresee that either the 2025 building code or at worst case scenario 2030, but I think 2030 it'll be too late. It's going to have to be the 2025 building code that brings in some rules around embodied carbon. And I think the first step that a lot of people are going to have to get past, and like it's kind of like what Edmonton's doing right now, is they're just requiring reporting. And so that's kind of the first stage is you don't have to prove reductions. You just need to report. And then after a couple of years of enough construction and enough archetypes, that you can determine, okay, like in our province, if you're building a mixed use residential building, this is all of the average data that we have for embodied carbon that was reported in. And so you have this information that you can create baselines off of. And then as soon as you have your baseline data, that's when you can go, okay, so if all of our mixed use residential buildings are coming in at 200 kilograms of CO2 equivalent per meter squared, then next year, let's try and do a 10% reduction. And so you basically put a number out there and say, we want everyone the following year to come back at 180 kilograms of CO2 equivalent per meter squared. And so, but you need that baseline number first before you can set a goalpost. And you can't get that baseline number without enough data. So you need that like chunk of time to incorporate enough data. And it really needs to be like province specific, because each province has different energy sources, right? Like Nova Scotia's power sources is a lot of it's coal, whereas PEI's power sources are a lot cleaner with It's nuclear, but it's still considered emission free.
Mm-hmm.
Yeah, so it's an interesting, it'll be interesting to see how the next few years roll out for sure.
Yeah, and it'd be really interesting. Sorry, folks, if you do have questions, you can put them in the question and answer chat below, and I'll or you can raise your hand and we'll let you speak. But yeah, no, it would be really interesting to see how that what they're doing in Vancouver, that incentive, kind of what the results are from that.
Yeah, so that actually got announced in the tail end of January this year. Like it's new.
Oh, wow.
But it's very promising because I think from learning a little bit about policy and how it works is sometimes you need the carrot and the stick. You need both of them at the same time to try and force change. And so this, the rebate and the amounts for the rebate are not small amounts. So it's a nice carrot.
Yeah, for sure. It would be great if other provinces could mimic that policy in some way. But yeah, will definitely be interesting to see what the results are for that policy initiative for sure.
Yeah. I don't know how much funding the program has. So I think it's planned to run until the funding runs out. And then they might have a revised rebate model after, which it may be more or it may be less, but I don't know.
Mm-hmm. Yeah, definitely something we should be looking at here in Nova Scotia. I did, when you were talking about all the provinces, I did like a quick search in our climate plan and for the word embodied, and it was like none. So.
Yeah, like I mean, probably leaders in the world. You're looking at like Denmark and Finland that are kind of like the European countries are kind of, they're the ones that have already started bringing in rules around embodied carbon, and it's because they were the ones to kind of incorporate energy efficiency way back in the like mid 80s, and so they've kind of learned it's not just all about operational energy. Like there's another whole piece of the pie. So now they're looking to address embodied carbon. So they're bringing in policy further ahead than what North America is at right now. So it would be great if we could just learn from not necessarily their mistake, but like learn from the time that they took and to realize that and just incorporate both operational and embodied carbon at the same time and address it both at the same time.
Yeah, for sure. And I know that like a lot of the Energy Sprong initiative, I know some people, it's starting to gain traction here in prefab retrofits. And I know a lot of those manufacturers are thinking about embodying carbon, which is great.
I think the Energy Sprong model is already being trialed in Edmonton, and it so far has been successful, but they have a few more buildings that they need to do to lower the cost down, and it's just a learning curve that they need to get past.
Yeah, for sure. We do have one question from Chris, who says, thanks so much for the information. Wondering if you have any thoughts for the activists on how to advocate for incorporation of embodied energy principle into national and provincial building codes.
It would, short of writing your MP or like the standards of building council typically releases a draft version of their code for review prior to officially releasing the National Building Code. And that would be an opportunity to get a copy of the draft, review it for embodied carbon, and then if there isn't, highlight it. But yeah, it would be your codes and committees for there's the national building code, but then also each province adopts their own version of the national building code. So you would reach out on the provincial side and try and address it on that end. So your Department of Transportation and Infrastructure would probably be and then also your Department of Sustainability on the provincial side. Those are the two groups that I kind of try and deal with here on PEI.
Okay, very cool. Because I know that the actual building code sits with the fire marshal a lot of the time, from what I hear.
Yeah, it goes. Unfortunately, a lot of like the building code always comes out and it's always more stringent, and then it always gets slowed down by builders that don't want the added cost of building to a more stringent level. So they will at times fight tooth and nail to have stuff removed, and then the final code that ends up getting released is always a watered down version of what it was intended to be. So like I think that will hopefully change. And it's going to have to change if like Canada and provinces are committed to try to hit net zero energy by 2030 and net zero emissions by 2050. I probably should have mentioned this earlier, but I don't know if it's aware for the people in Nova Scotia, but the reason I kept saying net zero emissions by 2040 or 2050 is because PEI 2 years ago actually committed to reaching net zero by 2040, which is 10 years ahead of Canada. So we have a completely different timeline that we are striving towards.
Okay, cool. Yeah, I feel like PEI has been taking a lot of initiative on a lot of climate action, so that's good to hear.
Yeah, they're trying to work out ways to potentially become energy independent, and so there's an island in Denmark, and they had a speaker come over, and Soren is the island, I believe, and they 10-15 years ago decided to become energy independent, and they did it, and now they're exporting their energy off the island, and they're completely net zero emissions. And now they basically started a school, and the owner tours the world and does presentations about how his little island did it. And Soren is quite a small island. Like I think their population is like 5,000 or 10,000, but the model that they used is potentially available to be scaled up and replicated.
Wow, that's really interesting. And something that I just read today, just in terms of like the work that PEI is doing, it was really interesting because it was across like all of the Atlantic provinces, and PEI has like a super high satisfaction rate for the work the provincial government's doing right now. And that was like across the board, but it's like 74% or something compared to.
Yeah, there's a lot of numbers being floated. I think a lot of that is related to the fact that the writ just dropped last week, and we're in an election cycle. Our election's early next month, so yeah.
Okay, well, maybe I'm missing some context.
Well, I'm sure like everyone seems to be very happy. So it is definitely a good sign.
I think that's great. Well, if we don't have any more questions from anyone, we might wrap it up there. Thank you so much, Valentine, for the presentation. It was super great. I'm definitely going to be forwarding this to some people to watch. Lots of really great information that definitely needs to be shared, and will be on our website for folks that missed the webinar.
Okay, perfect.
Okay, great. All right,
thanks
folks.
so much, everyone, for your time.
Yeah, everybody have a good night, and thanks for attending. And we'll have more information about our next Better Building speaker series on our socials and website once we get those speakers booked. So we will see you all very soon.
Perfect. Thanks a lot, Claire. Thanks, everyone.